Here we'll be doing word problems for 3 by 3 linear systems. And okay, I won't do as many as I did in the 3-6 because these problems are basically take twice as long, and they take a while to set up even. So I'll try and make this relatively sooner. Here we go. For problem 7, we have an artist who makes 3 kinds of statues: large, medium, and small. And we want to know how many of each, so we'll call it L large statues, M medium statues, and S small statues. Those will be the variables we'll solve for. The statues cost $5, $4, and $3 each, respectively. And they sell for $20, $12, and $9 each. They cost the artist that much, and the artist sells them for that much. How many of each type must she make and sell to sell 180 statues at a cost of $650 to bring in $2,100? Okay, 3 variables, L, M, and S. We'll need 3 equations. The first equation talks about the number of statues, 180 of them in all. So therefore, L plus M plus S equals 180. Now, the statues cost $5, $4, and $3 each, respectively. So the cost of the large statues is 5L, of the medium statues is 4M, and of the small statues is 3S. These add up to the total cost of $650, this equation here. And then the artist sells them. The large statues for $20 each, so 20L revenue there. 12 for the medium, each medium, so 12M for the revenue for the mediums, and 9 times S is the revenue for the small. And these adds up to the total revenue of $2,100, like this. Now, right, this is a 3 by 3 system, and okay, this way I'm going to first change it to the augmented matrix and do row operations on that, just to save a certain amount of writing effort. So 1L, 1M, 1S, 180. 1, 1, 1, 180. 5L, 4M, 3S, 650. 3, 5, 4, 3, 650. 20L, 12M, 9S, 2100. 20, 12, 9, 2100. Okay, we're going to do row operations to clear variables. Starting from this 1 here, I'm going to pivot on this column, meaning I'm going to after row operations, there'll be a 1 there and zeros elsewhere on its column. You have a 5 here. To eliminate that, we'll have to subtract 5 of this out of this. So we'll subtract 5 of row 1 from row 2. We have a 20 here, so we'll have to subtract 20 of row 1 from row 3. So here we go. First row is going to stay 1, 1, 1, 180. Second row, 5 minus 5 times 1 is a 0. Put a 0 there. This here, this entry here becomes 4 minus 5 times 1 is a -1. We put that there. This entry here becomes 3 minus 5 times 1 is a -2, which goes there. And this entry becomes 650 minus 5 times 180, which is -250. We put that there. Third row, let's see, 20 minus 20 times 1 is a 0. It goes there. 12 minus 20 times 1 is a -8. That goes there. 9 minus 20 times 1 is a -11, which goes there. And 2100 minus 20 times 180 is -1500. That goes there. So now here we go. All right, now what I do next is that I flip the signs on this middle row. So these are all negatives before, now they're all positives. Now I'm going to pivot on this entry. I'm going to zero out this 1 here and this 8 here. We'll zero this 1 out by subtracting row 2. Subtracting row 2 from row 1. I'll zero out this 8 here by subtracting 8 of row 2 from row 3. Middle row is still 0, 1, 2, 250. Top row, let's see. 1 minus 0 is a 1, goes there. 1 minus 1 is a 0, goes there. 1 minus 2 is a negative 1, which goes there. And 180 minus 250 is a negative 70, which goes there. Last row. Let's see. 0 minus 8 times 0 is a 0, goes there. 8 minus 8 times 1 is a 0, which goes there. 11 minus 8 times 2 is a negative 5, goes there. 1500 minus 8 times 250 is negative 500, it goes there. Now, this third row is 0, 0, negative 5, negative 500. This corresponds to an equation where x and y are gone, or L and M are gone, and S remains. Okay, so the thing to do is divide by negative 5. So we'll get a 1 here, get a 1 and 100, along with the rest. This last row corresponds to the equation S equals 100, so 100 small. All right, we're almost done. We want to have what's called a diagonal matrix. One's along the diagonal and zeros elsewhere. But that's not quite there. There's a negative 1 here and a 2 here. So we pivot on this entry. We'll take this and add it to that to cancel that out. Take minus twice this and add it to that to cancel that out. So row 1, we add row 3. Row 2, we subtract twice row 3. 1 plus 0 is a 1. That goes there. 0 plus 0 is a 0. That goes there. Negative 1 plus 1 is a 0. That goes there. And negative 70 plus 100 equals a 30. That goes there. Second row, we subtract twice row 3. 0 minus twice 0 is 0. That goes there. 1 minus twice 0 is a 1. That goes there. And 2 minus twice 1 is a 0. That goes there. And 250 minus twice 100 is 50. That goes there. So now we have what's called a diagonal matrix, and I guess the augmented dyadic matrix. So anyhow, this corresponds to the system L equals 30, M equals 50, and S equals 100. Therefore, 30 large statues, 50 medium statues, 100 small statues. Here we have a piggy bank with coins, dimes, nickels, and quarters. No one cares about pennies anymore. How often you've gone up to a store and, oh, I don't have a penny on me. Never mind. It actually costs them more to make a penny than it's worth. I really think it should be discontinued. And the nickel along with it. They're both money-losing propositions, and no one takes them seriously. Anyhow, never mind. We have these nickels, dimes, and quarters. Their total value is $6. There's 64 of them. And then they throw in this silly thing. If the nickels were dimes and the dimes were nickels, then the total value would be $5. How many nickels, how many dimes, how many quarters? So, okay, we give those numbers names. N for nickels, D for dimes, Q for quarters. The number of coins is 64. So N plus D plus Q equals 64. The value of the coins is $6, which I'll write as 600 cents. 5 times the number of nickels plus 10 times the number of dimes, so it's 25Q equals 600. Now here, if we swap around the values of the dimes and the nickels and evaluate 5 cents per dime and 10 cents per nickel, and get it $5, then means 10N plus 5D plus 25Q equals 500. Here is the 3 by 3 system. All right, here's the matrix. 1, 1, 164, 5, 10, 25, 600, 10, 5, 25, 500. Okay, I see a lot of common factors of 5 here, this row and this row. Oh dear. Okay, so what I'll do is, no, in fact, what I do is I pivot on this 1 here. Use this 1 to cancel this 5 and this 10. So we'll subtract 5 of row 1 from row 2. Subtract 10 of row 1 from row 3. And let's see. Well, first row is still 1, 1, 164. Second row, 5 minus 5 times 1 is a 0. 0 here. 10 minus 5 times 1 is a 5 here. 25 minus 5 times 1 is a 20 here. And 600 minus 5 times 64, that's 280. So 280 here. For the third row, 10 minus 10 times 1 is a 0. So a 0 there. 5 minus 10 times 1 is a -5. So a -5 there. 25 minus 10 times 1 is a 15. So a 15 there. And 500 minus 10 times 64 is -140. So -140 there. All right, at this point, these all have common factors of 5. So I think let's just divide both these rows by 5 just to simplify them a bit. And we get first row 1, 1, 1, 64. Second row 0, 1, 4, 56. Third row 0, -1, 3, -28. Okay, I'm going to pivot on this 1 in the middle here. Eliminate this one by subtracting row 2 from it. Eliminate this -1 by adding row 2 to row 3. So middle row stays 0, 1, 4, 56. Top row, 1 minus 0 is a 1. 1 goes there. 1 minus 1 is a 0. It goes there. 1 minus 4 is a -3. That goes there. And 64 minus 56 is an 8. That goes there. For the third row, we add row 2 to row 3. 0 plus 0 is a 0. Goes there. -1 plus 1 is a 0. That goes there. 3 plus 4 is a 7. That goes there. And -28 plus 56 is a 28. Now we're nearly done, because this third row corresponds to the equation 5q equals 28. And we solve that by dividing both sides by 7. So that's what we'll do, divide this row by 7. And so 1, 0, -3, 8, 0, 1, 4, 56, 0, 0, 1, 4. Now here we're going to pivot on this one, use it to eliminate this 4 and this 3. Third row, we add 3 row 3 to cancel this -3. Second row, we subtract 4 row 3 from row 2 to cancel this 4. And let's see. All right, fine. After we've been to the usual arithmetic, here we go. N equals 20, D equals 40, Q equals 4. 20 nickels, 40 dimes, and 4 quarters. Now, all right, there's more 3x3 systems, but like I say, it's most of the work is this tedious row operation stuff. The basic math of this is translating from English to math, which, as I've said before, is sometimes a bit of a problem. Anyhow, let's see, are we done here? Yes, I believe we are. All right. Bye-bye, robot.